This video is going to talk about the area of composite shapes. So first thing that we're going to do here is we are going to draw a line that divides these composite shapes, and composite means joined up. We're going to split these composite shapes into two simple ones. So we're going to break one complex shape into two simpler ones. For example, I'm going to put a line down here, and now we have two rectangles instead of a weird letter L thing. You might have seen splitting it this way. Either way is okay. This shape I'm going to split right here, so we have two rectangles, and I'm also going to split this shape so that we have two rectangles here. If I wanted to find the area of the shapes that I split into, this makes it a lot easier. I can see that the distance here is 3 and the distance here is 4. So 3 times 4, because I'm not going to use this split, goodbye, 3 times 4 is 12. So the area of this rectangle is 12. This rectangle measures 2 by 2. 2 times 2 is 4. This means that the area of the entire shape, 16 units squared. I go over here to this shape, and this is 1 by 1, 2, 3, 4. 1 times 4 is 4. Down here is 3 by 4. 3 times 4 is 12. The area of this shape is also 16 units squared. I go to this shape down here, and I could measure, and I could see 1 by 3 for this shape and get 3, and see 1 by 5 for this shape. So the total area of this shape would be 8 units squared. So I want you to look at how would you split each of these shapes so that there are two simple rectangles that we can find the area of. If it were me, I would split this right here. I would split this shape right here, and I would split this shape right here. There are some other ways you can do it. Some of those ways will make it more complicated than others. You can split a shape into as many shapes as you want, but the fewer that you split it into, the less chance you have of forgetting about a shape. So if I wanted to find the area of this, I would see that this rectangle right here is 1 by 2, which means it measures 2 units squared. This rectangle is 2 by 2, which makes this 4 units squared. This area is 6 units squared. For letter B, this is 1 by 2 right here, making this 1 times 2 is 2. Across here, this is 4. Down here, this is 2. 2 times 4 is 8. And 8 plus 2 is 10 units squared. That's our area. If you would like to check, you can go ahead and count the number of individual square units inside the rectangles. I'll let you do that if you choose. Over here, 2 by 1 is 2, and 3 by 3 is 9, making this area 11 units squared. They want you here to shade in the rectangles with their own colors and circle the dimensions that belong to the rectangles of the same colors. So for example, I'm going to do this a little bit simpler than the direction state. If I have the red rectangle and the black rectangle, the red rectangle, the dimensions are 2 yards and 3 yards. The black rectangle, the dimensions are 2 yards and 1 yard. Over here, the red rectangle's dimensions are 4 feet and 7 feet. The black rectangle's dimensions are 8 feet and 5 feet. So if I want to find the area of these shapes, I'm going to multiply the length times the width, just like normal. 3 times 2 is 6. 2 times 2 is 1. 6 plus 2 is 8. The area is 8 units squared. 8 times 5 is 40. 7 times 4 is 28. And 40 plus 28 is 68 units squared. Except you can see that I've used units out of habit when they actually tell me what the units are, so I should be sure to use those. For letter A, it would be 8 yards squared, and for letter B, it would be 68 feet squared, because they give me the units in the problem. Now we get to a shape that's a little bit more complicated. We get to a shape where we can see some of the measurements, but not all of them. So for the gray shape, we know that the vertical measurement is 4 and the horizontal measurement is 11. So we know that the area of the gray shape is 44 centimeters squared. Seems pretty simple. Now we just have to figure out the bottom. But for the bottom, we know that the horizontal measurement is 5. We don't know this vertical measurement. So we need to figure out, because this 7 tells us for this entire line right here, all the way top to bottom. But we don't care about all the way top to bottom. We only care about what's down here. We only care about this right here. So how do we figure out what this measurement is? Well, we're going to look across, and we're going to see that this 4 centimeters that's on this side of the rectangle is the same measurement on this side of the rectangle, which means that the scribbled out portion is 4 centimeters. So if this scribbled out portion is 4 centimeters and the whole thing is 7 centimeters, when I take the 4 centimeters out of the 7 centimeters, that only leaves 3 centimeters. Excuse me. This means that this rectangle measures 15 because 5 times 3 centimeters is 15 centimeters squared, which means this entire unit, 44 plus 15, is going to be 5 plus 4 is 9, 4 plus 1 is 5, 59 centimeters squared. Let's go ahead and let's find the length of this shape. And I can see here that I know this is 7 centimeters because of how it's centered. And I know that this is 10 centimeters. I know that here is 11 centimeters. And I know that this is 9 centimeters. So let's figure out some dimensions here. I know that for the white rectangle, it's going to be 7 times 10, or 70 inches squared. For the gray triangle, I know that this is 9, but I need to know the whole measurement over here. And I don't have the whole measurement, but I do know that from here to here is 10 inches, and that from here to here is 11 inches. So if I combine the 10 and the 11 inches together, that makes 21 inches, which means that the gray rectangle's area is 21 times 9 inches, because here's the 9 and here's the 21. And that makes 189 inches squared. So the area of the entire shape 189 inches squared, 70 inches squared. I'm going to add those two together. Answer's still going to be in inches squared. 259 inches squared. We have some practice shapes here that we can also find. I would like you to try to figure out this measurement right here. And I'd also like for you to look for this measurement right here. Go ahead, pause the video. When you come back, we'll talk about it. Welcome back. Let's go ahead and look at our measurements here. To find this measurement, we're going to combine this with this. 2 meters plus 1 meter is 3 meters. To find this measurement right here, I know that this whole thing is 3 feet. Take out the 2 feet. That leaves 1 foot. And for the sake of time, I'm not going to solve each one of these. What about this measurement? What would this measurement be right here? I know that this whole measurement is 3 meters, and I want to take out this 1.6 meters. So I'm going to subtract 1.6. I'm going to make sure that I line up the decimal point. 0 minus 6, can't do that, have to borrow. 10 minus 6 is 4. 2 minus 1 is 1. So this measurement is 1.4 meters. Now we have too many measurements, and we need to figure out which measurements are important and useful for us when finding the area. Which measurements do you think are useful for the gray area? If you said 13 centimeters and 5 centimeters, you were correct. Which measurements are important for the white rectangle? If you said 4 centimeters and 6 centimeters, you were correct. And then you would multiply to find your areas and then add them up. I want you to find the area of the shape both ways. You are welcome to explore with this. Assuming that you do your math correctly, you will find they have the same area. I'm going to go through these. I'm going to let you pause on one of those if you want extra practice. Remember that to find the perimeter, you don't need to break it into rectangles. You just have to be able to walk around the entire shape. To check that you didn't forget any sides, I would suggest that you literally trace over a shape as you go around, as you're finding perimeter, to make absolutely sure that you don't forget an entire side. Ladies and gentlemen, I hope you have an absolutely fantastic day.